Question 6 says, a stationary listener standing on the roadside records the wavelength of the sound emitted by the siren of a police car traveling at constant velocity. So I'm going to make a note here, a stationary listener. So that means that VL is equal to 0. Record the wavelength of sound. Okay. In the wavelength time graph below, not drawn to scale, lambda L is the wavelength of the sound recorded by the listener, and lambda S is the wavelength of the sound emitted by the siren. So from the graph, I'm just going to make a note. Lambda L is equal to 0.40 meters, and lambda S is equal to 0.38 meters. Take the speed of sound in air to be 343 meters per second. Question 6.2. Is the car moving towards or away from the listener? Give a reason for the answer. Now, I'm going to use an equation to explain this. The equation is V is equal to F times lambda. V is the speed of sound in air, and it is a constant value. Because it is a constant value, it means that F and lambda are inversely proportional. So because lambda L is greater, we have a greater lambda L compared to lambda S, that means the frequency will be low. So we're going to have a low frequency. And since the frequency is lower, it means that the car is moving away. Question 6.3.1. Calculate the frequency of the sound emitted by the siren. So V is equal to F times lambda. So 343 is equal to F, so that's the frequency, multiplied by the lambda. Now we need to be careful. We have lambda L and lambda S. We are interested in the siren itself, so the sound emitted by the siren, so the source. So we're going to substitute in 0.38. That means that the frequency is going to equal 902.63 Hertz. Question 6.3.2. Calculate the magnitude of the velocity of the car. Here it's worth 6 marks, so there's probably going to be more than one equation that's going to be used. The first thing I need to do is work out the frequency that the listener hears. So the frequency of the listener is going to be equal to, I'm just going to rearrange this equation from 6.3.1. It's going to equal 343 divided by 0.40, and that's going to equal 857.5 Hertz. Now I can use the Doppler formula. So since it is moving away, the formula is going to be FL is going to equal V minus VL divided by V plus Vs multiplied by Fs. Now we just have to substitute. 857.5 is equal to 343. The listener is stationary, so VL is 0, divided by 343 plus Vs multiplied by the source, which is 902.63, as we calculated in 6.3.1. Now we can rearrange, or we could use our calculator. Vs is therefore equal to 18.052 meters per second.